Welcome to You'll Be Blessed Education. This is You'll Be Blessed, aka Mr. Phillips in the chemistry classroom. And today we are going to embark on a journey of the addition and subtraction of measurements with sig figs. Now, if you haven't seen my previous video on the counting and identification of sig figs or the multiplication and division of measurements with sig figs, then please make sure you check those videos out because they will add to and increase your understanding in this matter. All right, so let's go ahead and begin. Our goal is to actually determine the number of sig figs in a measurement so we can apply the rules for sig figs in making scientific calculations. And our concept is that we use logic to determine how our measurements are represented, or logic determines the representation of measurements. Okay, we use the way we report a number determines how important the values are. All right. And so the same thing applies in determining the sig figs, multiplication, division, and then there's a slight difference when you look at addition and subtraction. So let's go ahead and begin. So the first thing we need to do is we got to find the measurement with the least number of decimal places this time, or the least number of sig figs. So decimal places or placeholders really play a role in the addition and subtraction versus multiplication. It plays less of a role. So, but the concept is still the same. The lowest number is So the lowest number of decimals or sig figs determines how many sig figs the final answer will actually have. So again, your final answer is only good as your worst measurement, hence the number of sig figs. All right. And again, if the calculations are done in sequence, then you will just round at the very end. So I'm going to go through 3 examples because I found that in my classroom, there was one particular problem that students had questions on. And so I want to make sure I cover not just 2 examples, but 3. Okay, so let's dive in. Our first example, we have 3 measurements that we're going to calculate in series: 3.95 grams plus 2.879 grams plus 213.6 grams. Okay, so we're just going to actually go ahead and add these numbers together. And when we do that, this is what the calculator will give us. It'll give us 220.429. Now, why do I have those last 2 numbers highlighted in red? Well, here's why. According to the rules of sig figs, your final answer can only be as good as your worst measurement. All right. In the case of addition and subtraction, and in this particular problem, it's the number with the least number of decimal places. And that means it is the most imprecise answer, meaning it has the fewest number of certains when it comes to measuring things with the same level of accuracy. So that number we identify with the least number of decimal places is 213.6. And so what that means is we're going to round to the same placeholder as 213.6. And when you do that, the 2 comes at, so the number that's in the same decimal place that's in the 10th place. So we can identify that the 10th place, the first place after the decimal, is where we're going to round. So that means when we get the final answer, we can only round to that 1 decimal place. So we have 0.42, 2 rounds down. So therefore, we are left with 220.4 grams. All right, cha-ching. And that's your final answer. So let's go on to another example where you can see why we might call this sig figs, because this is a very interesting measurement, but it really drives home the fact that some measurements that we make in experiments are just not important or significant enough to make a difference or change. So let's look at this one. This is actually a problem that I give in the classroom. Okay, so we have 0.1273 milliliters minus 0.000008 milliliters. All right. So what does all of this mean? Let's go ahead and plug this into a calculator. When we do that, we get 0.127292. So why do I have 9 and 2 highlighted in red? That's because we have to identify our number with our measurement with the least number of decimal places or our worst measurement. And so our least precise measurement, okay, or most imprecise measurement is actually the one with 4 decimal places only, and it is 0.1273 milliliters. Since it has 4 decimal places, we can only round to the 4th place. And therefore, we end up with the 9 after the 2, rounding that 2 back up to a 3. Therefore, we have 0.1273 milliliters. Wait, you mean we did all of that subtraction only to get the same answer that we started with? Yes, we did. That's why it's called sig figs, folks. Okay, if we were to, this is the example I can give you is that if we have a gallon of water and you were to take a drop out of a gallon of water, would you really notice the difference? Would you notice it? What if you were working for a beverage company and you were pouring out the amount of beverage, but the difference was so small you couldn't tell visually that the amount of liquid in every single bottle is actually not the same. It differs by maybe 0.000008 milliliters. That's what we're talking about here. This measurement is actually so small that if we take it away, it really doesn't even make a significant contribution. It is outside of our understanding. It is outside of our comprehension. And therefore, by the rules of sig figs, it doesn't even make sense to talk about it in this calculation. So that's why this, even though you can subtract a very, very small number, it is so small that it's insignificant and you end up with the same thing that you started with. All right. And this could be applied even if we added that small amount to a gallon of water. If you added just a drop, you would barely even notice the change. All right. So that's a great example of how sig figs really demonstrates the power of numbers and calculations that actually make sense in the physical world versus things that don't make sense. So let's go to our final example. Here is one of the problems that I get a lot of questions to in class, okay? And mainly because this one doesn't have a decimal place anymore. And so I've often had to clarify, or it doesn't have a visible decimal place. And therefore I've had to clarify many times, how to do this problem. And so in this case, because there's no decimal, the rules change slightly, okay? So even though we've lined up the numbers and everything, let's go ahead and just do the math. If we do the math, we get 934 grams as a measurement. But now, this is peculiar. Why do I only have 3 and 4 highlighted in red? It's because of one particular answer. If we were to count the number of sig figs in each one of these measurements, the one that has the least number of sig figs, actually, it comes down to 2 numbers. It's actually 502 grams. So 500 grams and 2 grams actually both have one number that is certain. We don't know, but the problem is 500 grams is our most uncertain measurement. It is our most imprecise. We don't know if that was originally 499. We don't know if it was 502. We just know that this is what was measured. It is our least precise answer. All right. So therefore, because it only has one sig fig and it's our least precise answer, no one really cares about the rest of the measurement. And so we actually round to the hundreds place. That is 3 places to the left of the decimal. And so we end up getting 900 grams rather than 334. And so what we're ultimately saying is, because 500 is our worst measurement, our final answer cannot be better than our worst measurement. So therefore, if 500 only has one sig fig and there's no decimal places, then our final answer can only have one sig fig. And that's why we have to round all the way down to 900 rather than keep it at 934. All right. So I hope you were blessed by this video today. I thank you for watching. If you were truly blessed, please leave a comment below. Also, like this video, subscribe to the channel, especially if you're looking forward to receiving some more chemistry content and becoming an expert or a master in your classroom. Okay. So again, thank you for watching. Be sure to check out the other videos related to sig figs. This is You'll Be Blessed, aka Mr. Phillips in the chemistry classroom, and I am out.